to my YouTube channel. So today we are going to see why we are using the logistic regression. So some of the time we know that the linear regression is for the continuous data and logistic regression is for the characteristic data or character data, the data which has the groups. But we should know that concept behind that, why we use the logistic regression, which problem or which limitation that linear regression have, but logistic regression which solve that limitations. So first of all, I'm drawing something here. So here I'm drawing one graph. So let's see, I want to predict the mark of or the checking that the I want to check that student is failed or not failed, student is failed or pass in the exam. So for that I have some data points. Let me put that data points. So here I have some data point. In my x-axis we have number of hours to study. Let me create header, number of hours, and in my y-axis we have marks. So here please ignore my drawing and all. So here we have some data here as well regarding my marks. So we have draw the linear line. Let's go with the linear regression approach. So here we draw one line which is the linear line. You can see here this line is look like this. So here I have some few data as well, data points. So here we can increase the data point here as well. So what data point this data point will give us like if I am just putting here one point which is called like 4 hours, and here which is connected to this one which is called 40 marks, we can say. What this diagram will show? This diagram will show that if you study 4 hours, then you will get 40 marks based on this diagram. So this is the linear regression line, right? So what we did, we just use the linear regression to find or to predict the categorical output. So here we are just trying this. So in that way we will learn that why logistic regression come into the picture. So here you can see that we have some data points and all. So here we have actually plot all the points. Now we can see that okay, I have to study 4 hours to get the 40 marks, right? So if my new data comes in this graph, so my new data look like this. So here just I'm adding few points, which is the heavy data which is come to the few points. So what if we retrain our model based on this new data, then my line will go below something like this. Let me use my line will go something like this, right? Because new point came, so gradient descent will be move my line to the little bit downward, because downward had some heavy data points. So that's why my gradient descent will do. Let me add a few more points here as well. Now you can see that based on the new data after the retrain my model, what I want to assume that, or what I want to get, if I want to get 40 marks, what I want to do, I want to study like this. This graph will go down, means this line will go down. So that's why my number of hours will increases. So my number of hours will increases to the 5. What this means, like based on the new data after train my new data with my model, it is saying that if you want to get 40 marks, then you need to study 5 hours. So this model is biased with my new data, because when my data which is present in this class is not changed, but only my higher class data is changed, and because of the higher class data change, my model is biased to my higher class. So its accuracy or its output is changed based on the higher class. So we can say that my model is biased with the higher class data. So if we use the linear regression in our categorical problem, we face the same kind of problem. If my some value or some data it changes, then my actually prediction or actually it affect the overall accuracy. So to solve this problem, how we can solve this problem? Because linear regression will not fit. You may say, oh, we can solve with the help of polynomial regression, but you can say that my this point and this point, in the middle of this point, we can say here we don't have any data which are present either on this category or this category, but not in this category. So how we can solve this problem with the help of graph? So let me draw one more graph here. So if you can see that I have few points here and I have few point here. So how can I draw the line which can solve this problem, or which can remove our biasness and will not affect our prediction if the new data will come into the picture? So to draw this line, we can use S type of curve. So linear regression is also called as the sigmoid regression because its curve look like something like this. So here you can see that we can add a few more point here. So here we can see that here is my threshold, and threshold is something like the value here. So if my data is below than this threshold, then we can say it's belong from class A, means student is failed. If my data is greater than threshold, then we can say my student is passed, means the result of student is passed. If the new data comes into the picture in this graph, then we can say this one line, right? The new data come in below like this. Then what should be the S curve? Then my S curve will be something like this. Something like this. You can see that the both S curve going to the same threshold point, means my threshold value is not changing because of the new data adding or new data because of the retrain of my model. So my threshold value is fixed. So because of that, the threshold value is fixed, and this is the way we can solve the logistic regression problem. So that's why our logistic regression come into the picture. If you go to the internet and see that what the logistic regression curve look like, you can see it's look like the S-like structure. Why? Because here we are putting some threshold value. So threshold value is present here, and if my data is below the threshold or my result is below the threshold, when we can say it's a class A, we can say it's a class A, belong to the class A, and if my data is higher than the threshold, then we can see class B. So if new data come to the picture, my S score look like this one, but my threshold is always similar or always same. We can choose threshold based on our data. Our model will choose the threshold based on the data, but threshold will never change once we decide or when we train model based on the few data. So that's why the logistic regression come into the picture. It is saying that because linear line will not fit this, if gradient descent will come and gradient descent will draw again the curve which are like different one, but this curve always go to the threshold point. So threshold point is very important in that case, and in that way our logistic regression will solve the categorical data problem. So but please keep this into your mind that our logistic regression is only for the two categories, not more than two, only for the two categories. For the many categories we have the different algorithms and different like formulas or theorems which we can solve the different category problem, but logistic regression only applicable for the two categories which has the bi-categorical data, which is true, false, male, female, and the spam, not spam, something like that. So our threshold is very important in the logistic regression. So this is the overall concept I want to explain. Why our linear regression fail? Because here there is no threshold or there is no value. Once the new data will come, our linear line will shifted and it will give me the output or results which are not accurate or equal to our previous one. But in the logistic regression case, our result is always similar when it comes to the new data or if it comes to the model change. So that's in this way I am going to explain you why the logistic regression. So You may understand this because sometimes people can write the logistic regression code within 2 minutes using the sklearn library, but you should know the concept behind that, why logistic regression we implemented, and where the linear regression fails and which problem logistic regression are going to solve. So that's the concept behind that. That's pretty much from my side. If we, in our case, we have to predict the result. If my value is below than the threshold, then we can say student is failed, and my value is above than threshold, we can say student is passed. So yeah, that's pretty much from my side. Thank you so much.